Find the derivative of f of x equals x plus 3 over x. And we also want to find f prime of 1 and f prime of negative 1. Okay, so we know that the derivative, right, we'll call that f prime of x, is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, now previously what we did is we would plug the 1 in here, right? So we would find f of 1 plus h minus f of 1 all over h. But then we would have to do that twice, right? So what we're doing now is we just find the derivative, right? The equation for that derivative, and then we can plug in the 1 and the negative 1 in there later on. Okay, so what this is asking for is just to find a general equation of the derivative. Well, let's go ahead and do that, right? So we're going to find f of x plus h. Okay, so we're going to, now you got to be careful with this, right? Because there's two x's in the equation. Okay, so we're going to get from this x, we're just going to put x plus h in there. And then also from that x, we're going to put in the x plus h. Okay, so this is f of x plus h minus the original function, which is, of course, still just x over 3 over x, and all of this divided by h. Okay, so once again, this is f of x plus h. This is just the original function, f of x. Okay, of course, still the limit as h approaches 0. Okay, so we do see that this cancels out, right? That's good. X cancels out with that x, that's good. But we still have, right? We still have this h plus 3 over x plus h minus 3 over x. Okay, so if we can sort of do this work on the side, I guess we'll call it. Okay, so we do want to simplify all this together. Okay, well, we just got three fractions, right? We got three fractions that we've got to combine into one fraction. So the LCD I know is x times x plus h. So we'll just multiply this by everything, right? So we get hx, x plus h, plus this fraction needs an x, so we'll multiply that by x. This fraction needs the x plus h. Okay. All over, of course, the LCD. And what happens here? Well, these cannot combine, right? So this is minus 3x minus 3h. So let me go ahead and write that again. So we get x squared h plus xh squared. Right, I'm going to multiply these two together. Plus 3x minus 3x minus 3h. Okay, all over the denominator. And once again, the only thing that happens here is that these two terms do cancel out. Okay, so moving back here, what are we left with? We are left with the limit as h approaches 0 of this guy. All right, we got x squared h plus xh squared minus 3h over x times x plus h. Okay. And all of that is still divided by h, right? Because we still have this one down here. Okay. Now, because we are just dividing by h, okay, it turns out that we can just flip that. So we get x squared h plus xh squared minus 3h. And this will just come to this denominator here. All right. So what happens next, right? Well, if you remember, if I'm doing this before, the h will always cancel out, right? Always. And if you notice, yeah, there's an h down here, but there's also each term in the numerator has an h in it as well. Okay, so let's go ahead and factor out that h. We got x squared plus xh minus 3 all over the h x plus h. So yes, they do cancel out, right? You got to remember that. Okay. So what are we left with? Right? I didn't write this each time, but that's okay, right? But we're still finding the limit as h approaches 0 of x squared plus xh minus 3 over x plus h. Now you notice what happens, right? Every other step along the way, if you plugged in the 0 for h, we would have got a 0 in denominator, right? That's not good. Okay, but what happens now? When you plug in the h here, as h goes to 0, right, well, that's just going to equal 0. And that's going to go away. So really now, what are we left with? We are left with x squared minus 3 over x squared. Right? And, I mean, you could technically leave this as a final answer, or we can split this up. X squared over x squared minus 3 over x squared. So that does give us 1 minus 3 over x squared. This, right, is going to be the equation of our derivative. Okay, 1 minus 3 over x squared. So then, what is f prime of 1? Well, we just plug in the 1 in here, right? So we plug in the 1 in here. That becomes 3 over 1. So 1 minus 3, which is negative 2. Similarly, what happens when we plug in negative 1 in here? Right, when we plug the negative 1 here, we sort of get the same thing, right? Negative 1 squared is just 1. So 1 minus 3 equals negative 2.